I have a problem with my chopper unit, but to demonstrate the problem I need to first use this R unit. I'm going to put this into a debug mode. It's not something that is advertised anywhere. So pay close attention if you want to play around with this debug mode, although you probably shouldn't. Here is our pairing button. Here is our switch to turn it on and off. Right now it is off. I'm going to hold down this button and I'm going to turn it on. I'm going to hold the button for 3 seconds and then I'm going to release it and press the button 3 times, and that's going to put the droid into a debug mode, and you'll see what it does. So here we go. Button down, turning it on. 1 1000, 2 1000, 3 1000. 1 2 3. Okay, so this is the debug mode, and BB units have it too, but it's not very useful for BB units. In the debug mode, it's not responding to a remote control. Maybe you can connect to it with Bluetooth and issue commands to it directly, but I haven't done any of that. I haven't tried that. But what I want to look at is how the head behaves as I rotate it myself. So if I start to turn the head, you can see the light turns on, and if I keep turning all the way, when I get to the end here, all the lights turn on. Then I start turning it back, it's just that one light. And as I get to the middle, either no lights are on, or this blue light is on. As I start to rotate it to the, or this is the middle, I guess. This is telling you that where the controller in the droid thinks the head position is. So it thinks it's in the middle right now, and there must be like an absolute middle there or a dead spot on the mechanism that detects this. That's your middle. That's the head from my perspective turning to the left. To the droid, it's turning to the right. Turn it the other way here. We're in the middle. Here we are. We're on the other side now. Keep turning, keep turning. And when I reach the end here, the limits that the head can turn, all the lights turn on. So you can use this to sort of look at your droid and its ability to detect where the head is. And that's what I want to look at with my chopper. So here is Chopper. I've removed the arms from the head. They just were getting in the way. And I'm going to do the same exact thing. There's the pairing button. There is the power switch. So I'm going to hold the button down, turn it on. 1 1000, 2 1000, 3 1000. 1 2 3. And you can sort of already see the problem. This chopper, for whatever reason, its head doesn't turn back and forth. It gets stuck on one side, always to the right side. So I want to turn on that debug setting here. So now we can look at the LEDs here in the head and see, what's going on. So I've got this red LED, but you can see as I turn it, it sort of goes off and on. If I push down, it stays on a little bit more, but it's still not perfect. And then if I go all the way to the end here, that middle light isn't turning on. Maybe it's detecting it's there, but it's not. Something's weird is going on here. So here we are back in the middle. Start turning it the other way. Oh, there's the other light. Turning it all the way here, and again that light goes out. The other lights aren't coming on. That's not a light. That's not a light. The other light is over here. 1 2 3 lights. There we go. The light's sort of back on, and it doesn't flicker as much if I push down a little bit on the head. But there's a problem here. There's a problem with this droid. It's not detecting the position of the head correctly, and we're going to have to really dig into this to try and fix it. We're going to have to start disassembling Chopper. The first thing I'm going to have to do is take the arms off, or the legs. I suppose it depends on your perspective. And you can see that this has an L, letting you know it's the left arm or leg, however you want to think about it. And that's from Chopper's perspective, so keep that in mind. Good. The screw, by the way, is captive, just like any R unit leg. like you would see when you're building one of these in Galaxy's Edge. I'm going to take the wheel out from the bottom as well. And now I want to get into the battery compartment here. I want to remove the batteries. The reason I'm going to remove the batteries is because I'm going to be digging into the electronics of this thing. And if I accidentally short something while the batteries are still in there, I could wind up destroying something, destroying the electronics inside. So I need to get in here and remove all these batteries. And you will notice they are the original batteries that came with this. And a lot of people have problems with the batteries that come with their lightsabers or their droids. Maybe it's just because some droids are sitting there for, you know, on the conveyor belt for maybe weeks, or batteries go bad and this might have been fresh. I don't know. I'm going to take Chopper's head off too. Again, it's just going to get in the way right now. I'm not too worried about that. And now we have to really dig in here. We have one screw here, one screw here, one screw here, one screw here, and then there are two more, one here and one here. So when I take these screws out, these screws are not captive. They're going to come flying out. So I need to make sure I don't lose them. So I'm going to take this little magnet here and just place the screws on the magnet so I don't lose them. There's one. All the screws are out. There are a couple that didn't fall out. They're still in here. So I need to be aware of that. So now I'm going to start taking this apart slowly. I would like to try and keep everything attached to the front if possible. But maybe I can't do that. Let's just see what happens as I separate this. Alright, yeah. Those just have to sit there. Okay, we have a couple of wires that we need to take care of here. We've got some metal rods here. Those go with these things. We'll take care of those later. Put them off to the side with the screws for now. This is the battery, and this is the pairing switch, and this is the switch, pairing LED and button power switch. And while I'm here, I'm going to try poking these two remaining screws out. I really don't want to lose them. I don't want them to come flying out when I'm not paying attention. Okay, that is the base or the back of Chopper, and I don't care about that. Here is the front of Chopper. So here is the main control board for a Chopper. It looks exactly like, and it almost certainly is exactly like, the R-Unit controller. We have the main microcontroller is here. It's an NRF 51822, I believe it is. It's got a little Bluetooth antenna right there, this little square wave thing you see there. And that is what handles communicating with the remote. It's what drives the motors. It's what... it doesn't control the LEDs. The LEDs... Or no, does it? It does control the LEDs, I believe. Or does it? I'm totally blanking on that now. These... They must, right? Because I'm wiggling that head back and forth. Anyways, the control board I'm not too worried about. What I'm more interested in is up in here. So I need to start seeing what needs to be disconnected so I can pull the head off. That needs to get disconnected, and that needs to get disconnected. And this motor here for the head. It's the yellow plug. Yep. Basically, I unplugged these three wires that go to the head. The wires that go to the arms I'm leaving plugged in, just so I don't have to remember which goes where. But if I wanted to remove everything, what I would do is I'd take a picture, or in this case I'm taking a video, with the PCB with everything connected, so I know where to plug everything back in when I'm done. Okay, now I want to take the whole head unit off. And you'll see it wants to come off. You see how, oh, it just fell out. Oh, yep, I'll put that off to the side too. That and that. You can see these things are used to sit in these little detents here to help lock the arm or the legs, I keep doing that, into specific positions. So those, we just need to remember when they go back in, they go with the bump pointing up. So for now, let's just leave that off to the side with all the other stuff. So the head, I want to pull it off, but it's sort of stuck here, and I believe what's keeping it connected right now is this gray plastic piece, and it should be just a matter of lifting up slightly, putting a little bit of pressure, lifting it over this little shelf here, and see, it comes right off. There we go. There's the front, or the chest of a chopper. That can go off to the side. I don't care about it right now. And here is the head unit. And we need to dissect this further. I want to separate the gray plastic part from this beige plastic part. And as I turn this around, I can see the white piece in the middle stays aligned with wherever it turns as the gray part turns. So I'm guessing those 3 screws is what holds the gray plastic to this housing unit here. And let's see what happens. Okay, now if everything goes as I expect, this beige piece should lift up. The motor should stay with it. This wire should stay with it. This wire should go with the plastic, the gray plastic piece, because I believe that gray wire goes to the contacts over here. And yep, there we go. Perfect. And now we can get our first look at the mechanism that tells, well, I gotta get this stupid wire out. Come on, there we go. All right, with the 2 halves apart, we can sort of see how the head position is being detected. On the plastic piece, which is what's rotating, we have this little gray, I believe it's called a brush. If we zoom in real quick, that's the brush. And the idea is that it's conductive. The brush presses up against the exposed tracks here on this PCB, and they create connections between the different tracks. And so as you turn the head, connections towards this pad means one thing. Connections with this pad or this pad are probably where it's too far to the left or too far to the right. And all these go connect to this piece, this wire here, which provides contact, or the connection to the main board that tells the main microcontroller the position of the head. And I'm looking at these tracks here, and they look a little dirty or pitted or something. Something isn't quite right, especially on this side. But this is what I think the problem might be. The problem might be that the brushes need to maybe be bent out a little bit more so they make firmer contact. But the pads themselves here, these traces might actually be dirty and need cleaning as well. So I'm going to grab some isopropyl alcohol and try cleaning it. Okay, step 1, a little isopropyl alcohol. Let's see if this does anything. I don't see any debris coming off there, so that might actually be pitting. Take a look in a minute here. I mean, the cotton swab definitely has something on it, so it's picking up something. So there was a little bit of dirt that the isopropyl alcohol cleaned up, but now I want to give this layer, or coat this, or clean this, however you want to think of it, with contact cleaner. I'm going to be using this stuff. This is called Deoxit, and I'm going to apply some of it to the end of a cotton swab, and I'm going to apply it with the cotton swab to the traces here, and I'm going to leave it there. I'm not going to wipe it off. You don't have to wipe this stuff off. It's not conductive. It's probably better if you leave a thin coating of the stuff on it. Now, it's a little bit oily, a little bit messy, so I need to take a few steps here to sort of try and keep things from getting incredibly oily because it leaves a film and it coats everything, and it's not fun. So I'm gonna take my cotton swab. Now if you have like a little paper cup or something, maybe it's better to just squirt this into a paper cup, a little bit of it, and then put the cotton swab in there. I'm just gonna sort of direct the stuff on the cotton swab and let the paper towel soak up the excess. I'm going to do it very slowly here. If I push full down on this button here to get the stuff to come out, it's going to spray everywhere. So just a little pressure. There we go. That's all I need. And now this thing wants to drip, so I'm going to put this off to the side to let it drip, and I tried to protect the surface here, and it's everywhere. It's all, yeah. Anyways, so there it is. It's on the cotton swab there, and now I am just going to just coat the whole thing in deoxit. And what deoxit does is it's going to get rid of any oxidation. It's going to help give you a clean metal surface to make good contact with the brushes that are on the other piece. And you know what? I'm going to put a little bit of this deoxit on the brushes as well. So, I mean, that's good. That's all I need. I'm going to leave it there. I'm not going to wipe anything off. I'm going to grab the other piece of the head here. Here are the brushes, and I'm just going to, you know, give this a little clean as well, just like that. And the brushes themselves look okay, but maybe if I bend them back just a little bit more, maybe that'll help enforce really good contact with the traces. And because it's a spring-like, the metal is springy, it'll bend back, so it's not pushing too hard against the traces, but I want pretty good contact. So that's it. Now we're at the point where I need to reassemble everything and then test and see whether or not this worked. So what about the orientation of this and this? You don't have to worry about it. As long as the screw holes line up, you're fine. Because this rotates on this. So I'm going to, well actually, first thing I'm going to do is push this wire back through the metal. Now remember, the PCB needs to be facing towards the brushes here, so I want to make sure I'm pushing the wire through the side with the traces exposed, so the wire is coming out the bottom here. If I do it in reverse, I'm going to realize real quickly when I try to put this back together I've done it wrong. There we go, that's through. Now I just need to align the holes, and there we go. And that's it. And in case you ever wondered what stops the head from rotating all the way around, this little piece of plastic right here runs into this little piece of plastic that's sticking down. And that is how it stops turning. Okay, so now I just need to screw those back in, those screws. Where are they? I hope I didn't lose them. That would be very unfortunate. Because I'm screwing into plastic, the first thing I'm going to do is I'm going to screw backwards. Hopefully get a little click so it seats into the threads. This helps ensure that you don't accidentally create new threads or strip the hole. Because it's plastic, it's delicate enough that you could do that. In goes the screw backwards. It sits. You can hear a little click usually, or feel it sort of seat into place. And then screw normally in. What's next? I need to put this back onto the body. Let's find that piece. Okay, so here is the body. That's the bottom, that's the top. This is where the head goes. And if you look, there's a groove here with a going all the way around with a little notch there, or something interrupting that groove. And if we look on this piece here, we see a notch that'll line up with that. So this is keyed, so it can only go one way. So this beige plastic piece is going to go into the groove here. Make sure it's in the groove on both sides. Now it's not going to go all the way in, remember, because this gray plastic piece needs to be pulled up a little bit so it fits over this, I don't know what you want to call that. There we go. And now it's in. Good. I'm going to start reconnecting some of the wires that came off of the head here. This connector is brown, so it's going to go to the brown plug. This is really easy. White connector is going to go to the white connector on the board. Yellow goes to yellow. Really, really simple. Oh, yep. Can't forget those. I need these two little pieces of plastic. Okay, they go here with the little lump or bump or whatever you want to call that facing up. Those go on both sides. And now what those do is those fit into these little divots here on the shoulder. Let's get that in focus. So I know that this side needs to face down because it has those divots in it. The other side, no divots. So that's how I know which direction this shoulder piece goes. And I'm looking at the grooves here to line up with this lip here. And then we can see there's a groove here that's going to line up with this. If all goes well. And there we go. And it's found one of the divots, the detents, whatever we want to call them. And that's sort of locked into place. Same deal with the other side. Yep. There we're good. We are locked into place. Now the next step is to find these metal rods, which hopefully you saved. And if we look right there, you can just see it. There is a hole. The metal rod is going to go in there. And the second metal rod is going to go into the same location on the opposing shoulder. Like that. Nope, not yet. There we go. Okay. Beautiful. We're almost there. I now need to put the back shell on. For the back shell, remember I have the battery connector and the pairing switch and the power switch. Those need to be plugged in here. The power switch wire seems to be the longest, so I'll do that first. And we have a red 3-position switch or wire or connector and a 4-position connector. There's your 4-position red, there's your 3-position red. So connect those as appropriate. Trying very hard to be mindful not to knock anything out of place like I've done, and if you do, no worries, just go back and reset it and continue. Alright, everything is connected. Now I need to put the back shell on. The alignment will be as follows. Those two metal rods are going to go into the holes here and here as I flip that over. There's also a lip on this this gray piece here that's going to go into a groove down here, right? And the this little piece here, which has the buttons on it, the pairing button, the power switch, the pairing light, is going to fit into this little socket here. So you need to sort of keep an eye on all of that as you're doing this. So take your time. There is no rush. Oh yeah, we also have to be aware of this piece here fitting into the groove in the top. But the nice thing is, because you have all these different pieces that need to fit together just precise, you know once it fits, you've got it aligned correctly. Okay, there we go. Yes, look at that. That wasn't so difficult, was it? Head still moves, the body seems, look. Oh, nope, there we go. That shoulder, which kept coming out of its position, came out of its position while I was reassembling it. Okay, that looks good now. The seams are tight all the way around. Everything looks good. Now, at this point, you have a couple of choices here. We could just throw the batteries in without even screwing it together and test. And, you know, this head will rotate. We'll put the head back on so we can see the lights. And we can see if it works. Or you can put the body screws in first, at least, just so you don't have to, you know, be mindful of that. Otherwise, you need to make sure when you're holding this that you're holding both the back and the front together like a big sandwich. So that's what I'm going to do. I'm going to put at least a couple of those screws in. So I'll just go drop them into the holes like so. And my screwdriver and start start screwing them back in. And same deal as before, I'm going to screw counterclockwise first until I feel the screw sort of slip down into the threads, and then screw clockwise. Again, I'm trying to prevent accidentally wrecking the threads in the plastic here. If these had a metal insert that you were screwing into, which the batteries do, they're metal, like basically nuts here and here, you don't have to worry so much about that. You're not going to strip those unless you really put some effort into it. So you don't have to worry about that. But when you're screwing into plastic, you definitely want to do this little trick of screwing counterclockwise until the screw finds its threads, and then screw clockwise. I'm not trying to screw these in very, very tight. Just, enough that my fingers start to slip as I'm trying to tighten the screws. That's all. Now I'm just going to go around, check every screw, make sure it's tight. Next step is to put the head on. We have a notch here, and we have a notch, or whatever you want to call it there. That is how I know how to line up the head. There we go. Okay. Head is on. Let's throw the batteries in, and then do that debug thing again. Let's see if the head now works. Everything is screwed back together. I don't have the legs put in. That's okay. I just want to test the head, because the head is what the problem was. Power is off. Push down the pairing button. Turn it on. 1 1000, 2 1000, 3 1000. Release. 1 2 3. Already I know it's worked. Ah, wonderful. If it was still having its problem, the head would have kicked all the way to the right or left, depending on your point of view, and it would have stayed there, but it came right back. So now we're in the center here, no lights. We go to the right a little bit. There we go. The light turns on, and look at that. It's not flickering at all. Keep turning. Keep turning. Oh, and there's another light. Yep. So the two lights are on, and that tells you that it's reached the end, where it'll then know it's turned too far and just start turning back. Now I'll keep turning back, turning the other way, turning the other way. Oh yeah, in the middle here, where are we? Where both lights are off, we're dead center. Now start turning the other way. Oh, do we still have a problem with that one side? Oh, nope, of course. I'm looking at the wrong LED. I need to look at this one turning this way. There we go. That LED is rock solid, not moving. Let's see if I turn it all the way. That is on, and that is on. Come back to the center. Now we're center, dead spot. Now we're turning the other way. Okay, so I feel confident that I'm not seeing signs of an issue here. I think everything is working. All right, good. Good. I am now going to put the arms back on. This legs, whatever. And I call these things shoulders too. And if they're not arms, then these aren't shoulders. These are hip joints. Okay, so this is an L. L meaning chopper's left. Yes, my right. Sure. It just clips into place, and then screw it down. And like the battery screws, this is a metal insert here that you're screwing into. You don't have to worry about stripping that. Again, unless you put some effort into it, and I am not challenging anybody to do that, because I don't want you to break your droid. This is a silly thing that I made a while ago, and I don't think I ever did a video on it, or did I? I did an early video, a breadboard version of this, but I made it a PCB. I have a little Bluetooth device here, and you can tell it via a serial port here what data to emit when it gets power. So I'm telling it to emit the equivalent of a location beacon that Chopper will react to, or any droid. And then I have this. This is a little infrared motion sensor that I've plugged in. I could have just soldered it directly to the board, but I have it socketed like this for whatever reason. And it's going to be powered by this little coin cell battery, and right now power is is off because when the switch is on the right-hand side, it's looking for power coming from the serial port, but there's nothing connected to it. When I flip it over here, this battery is going to power everything. The passive infrared sensor, when it triggers, is going to turn on this transistor, this N-channel MOSFET, which will in turn provide power to the Bluetooth device. And the Bluetooth device will sit there for 5-10 seconds emitting that beacon, and then it'll stop. And that'll be just enough time for Chopper to see it and react to it. So I'm going to turn it on. So we're done. And hopefully, if you run into a similar situation, this video will help you figure out how to fix it. It's applicable not just to C unit droids, but also R unit droids. And if you've got a BB unit, I can't help you. It's a whole different thing. All right, that's it. Good luck. Have fun.